So now we'll start the next circuit, which is single phase semi-converter or semi-controlled. Okay, semi-converter is semi-controlled bridge loaded with highly inductive load or RLE. Okay, highly inductive or RLE. So the existence, as we mentioned, the existence of the inductance or highly inductive will remove any effect of E on when you are conducting. Okay, so having the inductance, highly inductance, will make the current constant, so this E will not affect your output voltage. And as you can see, for semi-controlled bridge or semi-converter, that we have the freewheeling diode, so it will always operate with the freewheeling diode. So if you look at the directions for the current, so this is the current of the diode, the current of the thyristor, the current of the thyristor. So all of these are adding together into one direction. So I is always positive, and having this freewheeling diode, if you have any negative voltage appearing here, the diode will turn on, removing this voltage and making it zero, which means that because of the freewheeling diode, the voltage is always positive. So if we sketch the VI characteristic of this converter, we have only one quadrant. So compared to the fully controlled or the full converter, this one is giving you only V positive and I positive. If you remove the freewheeling diode, now you can have the negative voltage or you have the second quadrant. But the semi-converter is always used with freewheeling diode. So for the bridge, we can use it without the freewheeling diode. We can add freewheeling diode, but we can use it without. So it can be with freewheeling diode or without freewheeling diode. But the semi-converter, it is always having the freewheeling diode. Okay. Now we need to determine or we need to sketch V out, V in, and we need to find an expression for V average, etc. To do this, we need to see what will be the circuit for each operation mode, and then we need to see at which time this operation mode is happening. Okay, so here we will sketch the circuit a couple of times. So assume that the voltage coming from the source is positive, which will make this thyristor on and this diode on, and this one will be turned off, and this one will be turned off, and this one will be turned off. So this is the first mode when thyristor 1 and diode 2 is on. As you can see, we call this semi-converter because here we have a thyristor and here we have diode. Here we have a thyristor and here we have diode. So we are only using 2 thyristors instead of 4 thyristors in case of 4 bridge, which will make the cost for semi-converter much less than the full converter or the fully controlled, because the diode cost is negligible compared to the thyristor cost. And still you have control, because for the current to go through the thyristor, it will go into the load and it will come back through the diode. So although the diode is not controlled, but you have this thyristor in the path controlled, which will give you control over the whole path, because thyristor 1 and diode 2 will be acting in series, so controlling one switch of them is sufficient. So this is a smart move to reduce your cost. So instead of using 2 controlled switches in the same path, we replaced this one with just a diode and we kept only this thyristor as control. And the same on the negative cycle. You have two thyristors or 2 switches in series, this one here and this one here. So the diode doesn't have to be controlled because already you are controlling through the thyristor. Okay. So just what I'm going to do, I will sketch the circuit. So here we have this thyristor 1 is on and diode 1 is off, and here we have thyristor 2 off and diode 2 on, and the freewheeling diode is turned off, and here is our output RLE. Here is V out, I out. So the freewheeling diode is off, thyristor 2 is off, and diode 2 is turned on. And you have your source connected between these 2 points. This is V in. Okay, so this is during the first time. So we can see that I source is going through thyristor 1 and going through the output, coming back into diode 2. So we can write down that I source equal to I thyristor 1 equal to I diode 2 equal to I out. So this is the path for the current. And we can see that I diode 1 equal I thyristor 2 equal to I freewheeling diode equal 0. All of them are turned off. V thyristor 1 equal to V diode 2 equal 0 because they are on. Now to sketch V freewheeling diode, it will be sketched in this direction. So here we have V freewheeling diode. So if we do KVL in this loop, we can see that V freewheeling diode is negative V out, and V out is V source. So V out equal Vn. If you do KVL in the outer loop, you can see that V out equal to Vn, and V freewheeling diode equal negative V out or negative Vn. So here is V thyristor 2, and here is V diode 1. Also, if you do KVL, you can see that V thyristor 2 and V diode 1 equal to V freewheeling diode equal to V thyristor 2 equal to negative V input. And this is the situation when we have thyristor 1 and diode 2 on. The second option or the second situation we have when you have a negative supply and you are firing thyristor 2. In this case, thyristor 2 will be on and the current will go to the source, and then it will go back from the source through diode 1 into the source again, and thyristor 1, diode 2 and freewheeling diode are turned off. So here when thyristor 2 and diode 1 are on, so we will do the same as we did for the first situation. So we will sketch the circuit. So thyristor 1 is turned off, diode 1 is turned on, thyristor 2 is turned on, diode 2 is turned off, and the freewheeling diode is open circuit. And here is our load RLE, V out, I out. So this is thyristor 1, thyristor 2, diode 1, diode 2, and the source is connected here. Here is V input. This voltage is V thyristor 1. This voltage is V diode 2. V freewheeling diode. I thyristor 2. I diode 1. I source. So we can see during this operation, if you go with V out, so V out here is the head of the arrow. So the head of the arrow here is connected to the tail of this arrow here. So V out equal to negative Vn, I out equal to negative I source, or I source equal to negative I out, equal to I thyristor 2 equal to I diode 1. So I thyristor 2 is the same as I out, the same as I diode, but it is negative I source. I thyristor 1 equal I diode 2 equal I freewheeling diode equal 0, because all of them are turned off. V thyristor 2 equal V diode 1 equal 0, because they are connected or they are on. If you do KVL, you can see V freewheeling diode equal negative V out equal positive Vn. And this voltage is the same as V thyristor 1, the same as V diode 2. Okay, so these are the variables we have during this time. And the new case here is whenever your V out becomes negative. So whenever you have a negative and positive voltage across the load, the freewheeling diode will turn on, taking care of the current. So the current will be circulating in this loop. That's why we call it freewheeling. And all the other switches will be turned off. So in this case, when the freewheeling diode is on, thyristor 1, thyristor 2, diode 1, diode 2 are off. So all of them are off. So if we sketch the circuit here, thyristor 1 is open circuit, thyristor 2 is open circuit, diode 1 is open circuit, diode 2 is open circuit, and the freewheeling diode is open circuit. Here is RLE, V out, I out, and here we have Vn, and the freewheeling diode here is conducting. This is the only one conducting. And we can sketch V thyristor 1, V diode 1, V thyristor 2, V diode 2. So we can see that I source equal to I thyristor 1 equal to I diode 1 equal to I thyristor 2 equal to I diode 2. All of them is 0. So the supply here is open circuit in both sides, so no current will flow. I freewheeling diode will equal to I out. V out is 0 because you have the freewheeling diode shorting the output. The tricky part here is how we can find V diode and V thyristor. So if you do KVL in this loop, you can see that V thyristor 1 plus V diode 1 equal to 0. And if you do KVL in this loop here, you can see that V input equal to or plus V thyristor 2 equal to V thyristor 1. And don't forget that all the switches are identical, so they have equal voltage magnitude because they have almost the same resistance. So you can see from this equation that V thyristor 2 equal to negative V input over 2. So V thyristor 1 will be positive V input over 2. So V diode 1 will be negative V input over 2. And V diode 2 will be positive V input over 2. And these are the voltages for the switches, okay? So this is a little bit of a tricky part, how we can calculate this. Note they are all identical, so magnitude V thyristor equal magnitude V diode, okay? Because they have the same impedance, so the voltage across them will be the same. It's like a voltage divider between two resistances. Now, we know what will be the equations for each mode of operation. So this is one mode when thyristor 2 and diode 1 are on. This is another mode when freewheeling diode is on. And this is one mode when thyristor 1 and diode 2 are on. So the idea is to determine when we will apply each one of these rules. So let's do the sketch here. So I will do the same as we did before. So here is omega t. So I will use this as pi over 2. Here is pi, 3 pi over 2, 2 pi. So here is peak, 0, negative peak. So, and then 0 again, and the peak. So this is V input. The maximum here is V max and negative V max. And we will sketch for alpha equal to 60 degrees as an example. So here is alpha is 60 degree. So this is alpha for 1. Don't forget that we have only one controlled switch in the positive half cycle and one controlled switch in the negative half cycle. So in the positive half cycle, from the positive half cycle, we will wait 60 degree and fire the first. From the negative half cycle, we will wait 60 degree and we will fire the second, and so on. So here we can say that thyristor 1 will conduct and diode 2 will conduct with it. As we mentioned here, that thyristor 1 will conduct with diode 2, so the current has a complete path. So when you fire thyristor 1, diode 2 will conduct, and you will continue until pi. At pi, you can see that V will reverse, which means the freewheeling diode will conduct because you have a negative voltage across the load. So let's sketch our V out. Just I'm indicating the main points. And here is the firing angle alpha. And here is the other firing alpha. Here is the other firing alpha. So starting from here, V out equal to Vn. So I will sketch my sine wave. Here is Vn. So V out equal Vn. V out equal Vn. We can see at this point V out start to be negative. When V out start to be negative, the freewheeling diode will conduct, making this voltage 0. Then at this point, you will fire thyristor 2. So here we start to have thyristor 2 and diode 1. So when we have So here is V input equal V out. Here is V out equal 0. And starting from here, V out equal to negative Vn. So if we go up here, V out here is negative Vn. Here V out is Vn. And here V out is 0. So when we have thyristor 1, V out equal Vn. When we have thyristor 2, V out equal minus Vn. When we have the freewheeling diode, V out equals 0. So when thyristor 2 is conducting, V out is negative Vn. So what I'm going to do, I will take this voltage here, but I will reverse it. So this is negative Vn. So here V out is negative Vn, so I will sketch negative Vn. At this point, the voltage is trying to reverse, so the freewheeling diode will take care of the negative. So before this, the freewheeling diode was conducting. So here is the free. So here is the freewheeling diode. Here is thyristor 2. Here is the freewheeling diode. Here is thyristor 1. Here is the freewheeling diode. Thyristor 2 conducts with diode 2. Thyristor 2 conducts with diode 1, and so on. So as you can see that the output voltage is positive with the negative removed as the effect of the freewheeling diode, which is the case we had for the full wave rectifier with freewheeling diode that I asked you to do it as a homework. So here is alpha, here is pi, here is pi plus alpha, here is 2 pi, and so on. So we can sketch our V out. If we need to sketch I out, so I out is constant at its average value, I out average omega t, because we are assuming we have a highly inductive load. If we need to sketch I source, so I source in case 1 here, I source is I out. In case 2, I source is negative I out. And in case 3, I source is 0. So we can add here I source equal I out, I source equal negative I out, and I source is 0. So during this time, I source is positive I out. Here I source is 0. Here I source is 0. Here I source is negative I out. And then it is 0 again. So here is I out, negative I out. Also, we can sketch V thyristor. So let's sketch V thyristor 1. Please try to sketch as a homework V freewheeling diode. Okay. So from here up to this point, we have thyristor 1. From here to here, we have freewheeling diode. From here to here, we have thyristor 2. Then we have freewheeling diode. And before here, we have freewheeling diode. And we are looking for V thyristor 1. So V thyristor 1 here is 0. So the first case here is V thyristor 1 is 0. The second case here, V thyristor 1 equal to positive Vn. V thyristor 1. V thyristor 1 equal Vn. And the last case here, V thyristor 1 equal Vn over 2. V thyristor 1 equal Vn over 2. So when we have thyristor 1 here, the voltage is 0. When we have the freewheeling diode, it's Vn over 2. When we have thyristor 2, it's Vn, then Vn over 2, then Vn over 2. Just I'm writing down what I'm going to sketch for V thyristor for each period. And now we can do the sketch. So it is 0 during this time. Then what I'm going to do, I will sketch Vn, and also I will sketch Vn over 2, just half the peak. And then I will sketch my V thyristor 1. So here it is Vn over 2. So I will go through Vn over 2. Then it is Vn, so I will move to Vn. Then it is Vn over 2. And here it was Vn over 2. So this is V thyristor 1. So the peak here is Vmax. The peak here is Vmax over 2. So the peak here is minus Vmax over 2. And the peak here is Vmax negative. And this voltage is V thyristor 1. So just I'm following these values that we got from the circuit. With the same or the similar technique, we can sketch V freewheeling diode. So I'm leaving this for you as a homework, okay? And this is a circuit from the textbook posted online. And these are the wave forms.